Hello, I'm Dominic Hobson, co-founder of Future of Finance. My guest today is Bob Suh, founder and CEO of OnCorps, a provider of artificial intelligence services that combine machine learning algorithms with behavioral science. The goal being not only to cut the costs of labor and the costs of correcting errors in financial services, but also to help increase revenues. Bob, thanks for joining us.
Thanks for having me, Dominic.
Let's start at the beginning. What path did your career take that led you to found OnCorps?
Well, I had spent decades in the tech and tech services industries. I suppose some of it was, I was in charge of M&A at Accenture and, watching some of these founders, and what happened when we bought them. And then I think fundamentally for me, it was the feeling that, a driver who drives their own car never gets car sick, but a passenger always does. And so there's something about really running your own company that it doesn't mitigate any of the failures but you at least feel you're in control of them. And that's been great. I think the other thing is that I also knew that, particularly with artificial intelligence, there was a once in a lifetime opportunity to essentially, build the railroads as they were at the turn of the century, and that there was this major change happening in technology, which machine learning presented, that it would just be, to me, a missed opportunity to simply be in a large consultancy watching it happen or describing it.
Now, as I said in my opening remarks there, the OnCorps corporate personality emphasizes human behavior as well as AI and machine learning, which you've just mentioned. What is it about that combination which you think makes it more successful?
I can describe the first time we came to this realization. We were doing an app for a very large management company, very large asset manager. And we had built the system to use machine learning to look at currencies and flag exceptions. And in the interface, we just assumed that if we ranked the exceptions by the most risky according to the algorithm and the most material to the firm at the top, that they would spend more time on those than on the ones in the bottom of the queue. So it was intuitive in the app that you should spend more time on the harder problems. And we found, because we track mean resolve times for every individual in our platform, that they weren't doing that at all, that they were actually speeding through even the riskiest exceptions. They were resolving those as quickly as the simple ones. And we came to the conclusion that particularly in finding errors on data sets, the prevalence rate is so low that the system ends up presenting 99% false positives. And when you are conditioned to clearing false positives, you just go into autopilot as a user. And that's a behavioral problem. And so we realized, we did an experiment with Yale University where we asked people in Amazon Mechanical Turk to correct Ken-Ken games. Ken-Ken games are like math puzzles. And we gave them 50 completed Ken-Ken games with about a 7% error rate. And we were able to recreate this eye glaze syndrome, but then we used an AI to interrupt them when they were speeding through potential errors. And we were very successful at changing the behavior. And we realized this is the core of what we need to be focused on.
So the AI is actually prompting users of its outputs to behave in different ways.
That's exactly right. I think we found that, you have a relationship with apps the same way, and platforms the same way you have relationships with people. Some people you share only good news, some people you share bad news with. You do the same thing with apps. You realize that there's some risk in oversharing something or being too open. You do the same thing with apps. And so apps, in a way, to get correct information, need to be sensitive to that bias or holdback, and then prompt you to sort of self-correct.
Now, obviously, any AI or machine learning algorithm you have to identify problems where it's likely to be effective. Is it very obvious when a business problem is susceptible to being solved by AI? In other words, is there some sort of abstract set of criteria you can apply to any business problem to say, well, this one is likely to be susceptible to being solved or improved by AI?
Oh, definitely. I think that it's the best thing about AI is it's really just math. And I think we're surprised when we hear of AI teams beating world experts in chess and Go and even poker. And I think we are underestimating how much math is behind our decision making. And in some cases, some of us are good at that, and in some cases, some of us are bad at that, but we think we're good at it. But we I think, ascribe a level of intuition that simply doesn't exist when you look at the evidence of people's decision making. So we believe that many problems which are predictable, have enough data, have a narrow standard deviation. In fact, the variance on a distribution of 100 or 1,000 or 10,000 decisions is fairly predictable with very low variance, and where companies spend a lot of money on that intuition, then an algorithm is perfectly suitable to that.
Now, something you obviously need for the algorithm to do its work is a lot of data for it to consume. Now, having that data in a form that it can consume it can be quite hard to obtain. Is there some sort of standard solution to that problem too? The data gathering?
Yes, there is. And many teams will use this as an excuse not to solve the problem. There are many world-class machine learning teams that have essentially started their algorithms, kickstarted it essentially with what are known as policy settings. In other words, at YouTube, before they had a lot of algorithms, they just realized the last video you saw is indicative of the next one you will want to see. That's just a policy setting. So there are many ways that you can set up a system to operate on these simple rules, but then learn about the variances and learn about the conditions and the context where you are departing from what the algorithm might have normally thought. So one way is to simply start with policy settings and then learn and accrue data through use. Another way that we use quite frequently is to create decision simulation games. And what we do is we work with Yale University, and we've worked with Accenture Banking as well on this, where we create fairly sophisticated decision-making games. And we are doing two things in those games. We're trying to change conditions where you might normally make a rational decision, but we're really trying to see under stressful conditions whether you'd make the same rational decision, for example. So for example, we did an investing game, and if you thought you were an investor and not a trader, and you self-declared as an investor, not a trader, would you stick to that reasoning when the market sold off? So we were able to actually simulate different market conditions. And we found that people can be very susceptible to changing conditions and to reinforcement learning agents or behavioral agents, particularly presented by social networking firms and advertising-based platforms, that they are very susceptible to those cues. And so we believe that it's actually very easy to create this simulation, build a body of data that's essentially a simulation, but it's closer to a real world decision than you might think. And then we've been able to field test those decisions as opposed to waiting a long time for data to exist.
You've described very articulately there where I guess AI has malign consequences. We're kind of familiar with that from Facebook, and you've just begun to describe how you see it in retail investing apps, which people use as well, where they're kind of encouraged to do more trading or to trade ineptly, or to trade to generate fee income for the provider of the app. Tell us a bit more about that. Tell us about those experiments that you've run and what you can do to correct them, because you've already talked about the sort of nudge factor here, how you can nudge people to behave more rationally, just as the malign apps nudge them to behave less rationally.
Well, I think first, we're still obviously in the early days of machine learning, and we are in an unfortunate situation where the best talent are being paid by companies who make money on advertising. And so obviously that leads you to a certain type of app and a certain type of algorithm. We know that people, just by their nature, are susceptible to social herding. It doesn't even have to be technological. We're almost programmed to be to be sensitive to what other people in a crowd are thinking or doing as well. I think that from our perspective, the same technologies that social networking firms and social trading platforms use, obviously people think those platforms now, the conventional wisdom is that they are stepping over the line. It can be very dangerous, that sort of thing. It's not all, wonderful and open sharing and about communication. It has a very dark side to it. But what we have found is that we can almost completely unwind those behaviors using the same social cues. And in other words, an algorithm and a person are kind of indifferent to what triggers a change in behavior. So if it's social cueing, we have found, and we were actually quite surprised, that we could replicate. We created an app that was like a social trading app, like some of the more popular meme-based promoters of stock trading. And we did that with Accenture Banking, but we also found that we could unwind herding kind of trading behaviors using the same technology and essentially promoting the idea of conservative buy and hold, the values associated with investing versus trading. And when we would remind people of that they would essentially go back to a more conservative trading stance. So what our conclusion was, people are just influenced by the last thing they hear, obviously in the right context. So we used an algorithm called contextual bandits, which is a form of deep learning, but it learns to use the right message in the right context. So it might be when the market's particularly volatile versus stable, when your portfolio may be down. Those are contextual cues that the algorithm might use. We were surprised that the algorithm was quite quick to learn how to essentially unwind herding trading behavior and get people to stick to their more rational behaviors. And so to us, it's quite quite a breakthrough.
Sounds like a very useful feature for wealth managers who face compliance problems in ensuring that investors are protected or that they don't sell investors inappropriate products and services, I guess. Is this where you've talked about AI with EQ? Is what you've just been talking about what you mean by that?
Yes, definitely. We believe that there is an entire realm of machine learning that's only being scratched very lightly right now. And so I'll give you an example. And we are working on, and I'll get back to this in a bit, but we're working on, for example, a skeptical algorithm. When you think about that, there's nothing that scientific about it. Your own mother asked you when you were 7 if you brushed your teeth. And your mother would, you say, yes, you did. Your mother might say, I didn't hear running water. And you ran up and down the stairs too quickly. And so that's essentially using high EQ to come up, to be skeptical, essentially. Well, apps can do that as well. Apps can use other contextual variables, like the amount of time you spend on something, or even, frankly, the variable that makes the most sense in this case is your intrinsic motivation. You know, if you're down and your portfolio is down, or if your sales are down, you know, what's motivating you to give a certain type of answer. But it can be other variables like the time you spend and everything. And so those are very, very important ingredients to understanding whether the answer you provide a system is valid or not. And the up to now, you know, we live in a realm, again, where most of the machine learning is from advertising-based companies. They don't care whether you're right or wrong. They just care whether you click. So, you know, whether it's good for you or whether, irrespective of what people say, the primary objective is get you to click. And so, you know, obviously with asset managers and financial services firms, there's much more of a complex objective function, which is, when you clicked on that, did you really mean it? Or, you know, can we trust you? You're attesting to something. Can we really trust you? And that's a level of complexity that we think requires learning, frankly, from high EQ people who are high EQ. And that may be where intuition is really potentially very helpful.
Mm-hmm. Now, we may have got ahead of ourselves a little bit here. Can I ask you, talking about asset managers and other institutional firms making use of AI, go back to my earlier question about data. Does data have to be in structured, easily accessible forms before you can put the algorithms to work on it? This is a complaint or excuse we often hear from firms saying, well, our data is scattered across 15 different databases. Some of it's in Excel, some of it's in SQL, some of it's in some other database technology, and bringing it all together to put the algorithm to work on it is basically so time consuming, we're not even going to start. So how important is it that the data is in a structured, easily accessible format, or are there ways of getting around that challenge? Because it is a challenge inside lots of financial institutions.
Yeah, we haven't found it as large a challenge as other people say. And we use quite a few unsupervised algorithms that simply try to learn and predict from what you give it. Mm-hmm. And we're often surprised by how much an algorithm can learn in an unsupervised fashion, even with limited data. We're also, I think, surprised at the fact that some data that you might push for integrating, it might not be as valuable as you think, you know? And it's very hard to know that until you get the data and you can compare the variables against one another. So I'd say it is difficult, but we're very confident that we can make tremendous strides in predictions with the data that are simply available. We have.
Mm-hmm. So it actually improves the data quality once you've started throwing the algorithms at it. Is that possible?
It essentially can first tell you which data matter. That's a very tough thing for a machine learning algorithm and a scientist. There's so much noise that much of machine learning, really, the best part of machine learning is about essentially, they call it de-dimensionalizing data, but it's essentially ruling out indicators that just don't matter and really reducing the data set to often 1/10 its size to the variables that really matter, that really have proven to predict the thing you want to predict. And so we often spend most of our time reducing data sets significantly through this technique. And it's often with data, we often rule out data that many people think are important.
So it's more about focus than it is about reordering and restructuring. Now, you've used the word prediction a number of times there. I've got a book sitting on my desk next to me, actually, called AI Prediction Machines. Is that a reasonable summary of what AI is?
Yes, essentially, an algorithm is trying to predict something continuously. So a self-driving car algorithm is trying to predict whether you should turn the wheel left or right based on what it sees right now in the current context. And so it's constantly predicting things. We have an algorithm, the same type of algorithm as a self-driving car algorithm. It's a deep learning algorithm that tries to predict whether your nav report will be late in the evening, but try to predict it in the morning. And it's actually 93% accurate. So we are realizing that the things that make for really tough operational management can be mitigated through these predictions earlier in the day. In other words, you can preempt what your toughest challenge would be that day. And if you can learn that in the morning through an algorithm, then you can, better manage your time during the day.
I'll come back to that nav point. This is a very interesting
Sure.
one and crucial to our audience. But one other sort of high-level question I'd like to ask you: people often lump together AI and machine learning with robotic process automation. Now, robotic process automation is something completely different, I think. So where do you see the difference between what machine learning algorithms do and what robotic process automation is? And what are the pros and cons? I sometimes hear from people that the error with robotic process automation is people are automating something which is already a messed up process rather than trying to rethink it from first principles. But tell me, what's your view? What's the difference between AI and robotic process automation?
I think the fundamental difference is that robotic process automation tools aren't geared to learn and improve. They're essentially geared to reducing the rote work that teams of people in operations have to undergo every day. What I would say, as stepping back just a bit, is that robotic process automation is a product of the software industry, and the software industry isn't necessarily synonymous with the machine learning industry. I will predict that the machine learning industry, to be really effective, will break rules that the software industry previously thought were sacrosanct. So, for example, the software industry tries to sell the same thing to hundreds of thousands of people or companies the same way. And that's essentially the model. That's almost impossible to do with machine learning. Machine learning is, in our minds, a craft of problem solving and mathematics and scientific experimentation. And while there are dimensions of it that will be productized, moving too quickly to the productization of it, I think makes for some messy outcomes. And, I think it's also clear, and we're clearly going through an unwind of this in what is clearly a bubble. In a bubble, I think it's very common for firms to overstate the potential of their products, because how else are you going to explain your valuation? And that doesn't serve machine learning well either. So I think that at the end of the day, machine learning is hard work. It is a craft. Just as if you talk to some of the top mathematicians in the world, they don't see it as cut and dry. They see it as an extraordinarily creative field. And so we see the same. We see machine learning as a creative field that can't be slotted into a, productized, scalable, totally productized or totally scalable business model. And the RPA model has kind of fit into that traditional software model. And because of that, it's been difficult for it to solve more complex problems.
Now, what about the cloud? I'm not really quite sure what I'm asking by this, but the cloud, you can get software as a service, you can get a platform as a service. Is there some aspect of the cloud which makes AI easier to adopt? Is the cloud essential to what AI is able to do? What's the interaction between these two technologies?
I would say the biggest benefit of the cloud to artificial intelligence is that you can just massively train an algorithm with participants from all over the world, or with easy access. I'd say the second, there's no reason why cloud architectures in themselves make machine learning necessarily better, not from a practical perspective, but I think certainly gaining access to thousands or hundreds of thousands of participants quickly is a huge advantage. In our decision simulation games, we're able to get 1,000 experimental decision makers from Amazon Mechanical Turk in 2 hours. We couldn't do that without the cloud. So that's certainly an advantage. But I think there's a huge change happening in machine learning, particularly in financial services, from siloed algorithms where each firm tries to recreate the same conditions and predictions, to shared algorithms, which are essentially the same algorithm contributed by multi-parties. Because when you think about financial services, most of the transaction problems we have are caused because we live in a multi-party, multi-book of record world, and it's the passing through of data, from state to state to state, that causes errors or issues or challenges and drive up operational costs. So to us, it just makes intuitive sense that the only way to solve a problem like that is to have a shared algorithm.
Now, a shared algorithm assumes that there would be shared data before that as well. So are you saying that AI could do more and be more powerful and progress more quickly if, in the financial services industry, asset managers, banks, insurance companies, and so on, actually agreed to collaborate with each other and to share their data, whether they do it through the cloud or some other means? But is data sharing central to accelerating progress here?
I think it's inevitable. And, we have told industry leaders to compare the airline software industry and the hospital software industries. In the airline industry, while in the early days of online reservation systems, while several major airlines had competing projects, they converged and standardized so that at any given time, any passenger, any airline can see the statistics. They can see the bookings and the turnaround times of planes and the prices, and it's just completely transparent to everyone. And that has been good for the airlines, and it's been good for the customers. In the hospital industry, you get a bill from a hospital of course, we're in the US where we get these huge bills for small procedures.
Mm-hmm.
Unfortunately,
Yeah.
you have no idea you can't compare that to anything. So there's no transparency, there's no improvement. And given the fact that, like the airline industry in some ways, or the transportation industry, it's really, the data are derived from multiple parties, then it makes more sense to have multiple parties seeing the same algorithm.
Mm-hmm. How does one manage this issue then of getting large firms to adopt this? If the benefits are so obvious that if people start to pool their data, to put it crudely, yet you see that individual firms struggle to adopt new technologies such as AI. I know they haven't got the budget, or they believe the benefits are exaggerated. Well, we're all in our 60s and we don't want to bet the firm on some new technology which might not work. So at the level of the individual firm, you see a reluctance to adopt AI technologies. But what you've just been saying is that at the level of the industry, the benefits become obvious pretty quickly, and not just, to every individual firm can benefit from it. So what in your experience explains the reluctance of the individual firm to adopt AI, and explains their reluctance to collaborate with each other to generate benefits?
Well, first of all, we have not seen reluctance. We are working with some of the larger asset managers in the world, and they have all indicated to us at the very senior levels that they are willing to share their information with counterparties because they believe that a rising tide will lift all boats. They also know that they'll be able to share in some of the technological costs. So there's some efficiencies to be gained as well. I think also maybe it's a self-selective crowd because we're moving farther ahead with our customers, that those customers are more enlightened, and we all realize that, well, unsupervised algorithms can find all sorts of nice things. Ultimately, the most accurate algorithm needs root cause attribution from the right party, and that often requires cooperation across multiple companies. And you only get that realization when you tried everything else with unsupervised algorithms or anomaly detection algorithms, et cetera. And root cause attribution is extremely powerful, but it requires cooperation. So we've realized with our customers that, we can only go so far with algorithms. Now, not a lot of companies, I think, have progressed that far. I think that they will, and then they'll realize what we're realizing. It's not that we're that much more insightful or innovative. It's just you basically hit an attribution wall when you only use your own data.
Something else I hear is that companies embark on these projects. They're very enthusiastic about it when they start, and all these theoretical benefits are going to flow from it. But when it comes at the end of the project and the machinery is in place and it's working and operating successfully, they're not so good at capturing the benefits of that investment. And, to give you a crude example, if it enabled them to cut their workforce, they tend to not want to do that and try to redeploy these essentially redundant workers. Has that been your experience as well? They're good at thinking about the benefits in theory, but not so good about capturing them in practice.
Well, I think the benefit of being a startup is that we have to prove the economics of our solutions or we won't grow. So we make it a standard practice to baseline costs before we introduce algorithms. And in fact, it's my belief. So one thing, just as a bit of a illumination on what machine learning specialists do, they are most of the time dealing with a set of data, and they are comparing 2, 3, 4 algorithms against one another to see which one will be more predictive and more accurate. I told my team, humans are algorithms too. Humans make very algorithmic decisions, not reliably, but humans often make decisions against a pattern. So we can consider that an algorithm. And so we, as a regular practice, compare human decisions with algorithms to see which one is better. And in many cases, particularly for rote decisions, algorithms are better. In some cases where there's a special circumstance or a condition and a great deal more real life experience creates a better answer, then the human is better. And I think that, that is where the interplay between humans and machines seems to make sense, is that the machine can't possibly learn everything, but it can take over some of the more rote decisions. And when you do something like that, you just treat the team as essentially as an algorithm and compare it against its false positive rate, its true positive rate, false negative rate in what we call error matrices or confusion matrices. And then it's just very straightforward.
You've just described humans as algorithms, which is a kind of counterintuitive way of looking at how humans work with AI and machine learning devices. We're always being told that AI is basically just a vast data crunching machine, and you actually need the humans to take the decisions. In other words, you throw exceptions at the human and say, well, could you please decide this for me? The machine can't do that. Is that division between the human labor and the machine labor actually inaccurate, and there's a more integrated way of looking at how humans work with machines?
I think that it depends on the person, and it depends obviously on how you set up the algorithm. There's clearly a need for humans to understand the context of what they're asking an algorithm to do. And algorithms need a great deal of fine tuning. I think some people think that algorithms are just completely self-learning, will take any data, take over the world. We just don't believe that. We think that an algorithm is only as good as the designer, and the designer has to be a human. Currently, many of us just think of designers as very technical machine learning experts. But the truth is that, and the reason we're successful, is we see designers as business specialists and industry specialists who understand patterns and understand exceptions and can help us tune the algorithm, to reduce its false positives, essentially. And so there's definitely a role. That said, I think that people will be surprised. People will be very surprised at how much algorithms can do.
Is it obvious? You used the term earlier about machines taking over rote tasks, if you like. Is it obvious now what ways machine learning algorithms and human beings can work together most productively? Is it taking away that drudgery, that rote work? Is it dealing with those errors? Is it even dealing with dishonest behavior by employees? Is it obvious now how machines and people can work together most productively?
I think it is. I heard a podcast where Elon Musk was describing elevator operators and saying, it now seems ridiculous to see a person manually operating an elevator, and we take that for granted now that that operation, switchboard operators, is the same thing. If you look at old movies with switchboard operators, you realize how mechanical that duty was. And there is a lot of that type of work in operations in financial services, just because of the burden of product and regulatory changes moving so quickly, and combined with the fact that we have so much legacy, so many layers of legacy systems. So it's just it's just faster to create a team to do the workaround and the recon than to, redesign the system. So there's no doubt in my mind that there's just a great deal of work that can be removed, and we're finding generally 90% of the baseline work can be taken out. I know, why hasn't RPA done that? Mainly because our algorithms specifically not only automate the work, but automate the decision making. Not all decision making, but there's enough decision making that our algorithms automate that we are able to get to about a 90% labor tech. Now, there's a very large custodian bank that has something like 25 or 30% annual turnover in its operations. In other words, it's not great work, And so within 3 years, they wouldn't have to fire a soul, and they could essentially fully automate their operations. So I'm not as worried about it. I do think that in the sort of timeline of automation, it's elevated work. It's elevated not only manual work, but knowledge work. And it's really just up to people to elevate their scope and knowledge and expertise, and not identify with I am a miner, or I am a clerk, or not to identify with the work, but to identify with problems that you are trying to solve in your given sector, and to be indifferent to who does the work, but to be more adept at how you help solve that problem. And I think the people that can do that will, they'll end up having much better lives, much better work, much more fulfilling work, certainly.
So where does your view lie on this spectrum between the optimists on the one hand, who say, as I think you've just been saying, that actually AI can make your work more fulfilling. You cease to be a bank clerk and you become an intelligent problem solver, so your work becomes more fulfilling. And on the other hand, there's all these people, and you've just mentioned you can take out 90% of the costs. Does that also mean you take out 90% of the labor? So you've got this long spectrum between the pessimists who say everyone's going to lose their job, and on the other hand, you've got the pessimists who say, well, actually, nobody really wants to be a miner or a bank clerk. You can have much more interesting work. Where does the truth lie between those 2 points of view? Does AI create more but more fulfilling work, or does it take away so much work that there's a kind of problem of mass unemployment?
I think it would be naive to think that algorithms can't fundamentally change the operations of large banks and financial institutions. When you really examine the work and the decisions being done as we have, it's just highly predictable. And so from my perspective, it's not going to be as pretty as we all might think. But you never know how quickly firms will adapt. But I believe the financial industry, especially when there's money to be made, there's a strong motivation to adapt quickly to technology. So I don't think it's as rosy as some people think. I think that the truth is that we have allowed ourselves to pay people quite a bit of money to do highly routinized decisions, to make highly routinized decisions. And that has all been elevated by a financial situation that's obviously been, there are all sorts of things about our financial world that are we're essentially arbitraging arbitrage, if you will. And so decision making is a part of that. I'd say that we are, it is very possible to radically reduce the headcount in operations. And I believe many institutions will take that opportunity. What that means for people, I think that there's always been time in major technological upheaval where people have had to step up. And I think education and retraining is critical, certainly.
Let me get specific now on some of the projects you've worked on. You mentioned earlier the predicting whether a net asset value calculation will be late, for asset managers. Tell us a bit more about that, and tell us about some of the other projects you're working on. You've mentioned OTC derivative trade breaks and margin calls, regulatory reporting, one of the things, and expenses, exceptional. Give us a flavour of some of the specific projects you've worked
on.
Sure.
Probably the best way to describe it is how people experience OnCorps systems every day. And what I can say is every morning, teams of people at some of the largest asset managers wake up, they see a prediction on which of their custodian banks will be late that day with 93% accuracy. And they are able to then call those banks that are, predicted to be late and double check certain things preemptively, and then also arrange their schedules and workload and time accordingly. And that's been tremendous. And we started using tree-based algorithms, but we now use more deep learning algorithms. And those because every day we know whether we were right or wrong, the deep learning algorithms can essentially get better and fine-tune themselves. And so we've been able to substantially reduce false positives, which is key in machine learning predictions. So that's one area. We've also applied anomaly detection, the same kind of algorithms that banks use in anti-money laundering. We used to spot errors in NAV production. With great accuracy. We back tested it against actual errors. Obviously, the error rate on NAV is so low that it's not like you would know you're right every day. You might every month or every quarter. But so back testing becomes essential. And so we have added, I think, a dimension of oversight, a level of mathematical analytics that most firms just don't have now. And they're relying on the sort of the 4 eyes and have somebody check this kind of thing. And I think you realize the great irony in our world in financial services, where when something goes wrong, regulators say somebody needs to look at that. But if you knew what I knew about when people look at things, do they always find errors? You'd question the logic of human oversight. So algorithms are actually quite good at it, and you can tune them so that they can find things that humans can't. In derivatives, again, a very complex process with multiple parties, often with complex contracts. And we have trained an algorithm to read the contract, even in its PDF form, and to read it for economic and legal variances, and then go search through the electronic trading record to make sure that they match. That simple task for a complex derivative can take a very high-paid middle office analyst 2-3 hours, and our algorithm can complete the task in about 2 minutes. So it really accelerates the ability for an analyst. In this case, the analyst is still needed, but they are getting all the grunt work done. The matching, the sorting, the reconciliation is all complete. And now they have the task of essentially following up with the counterparty or the portfolio manager, whatever, to make sure that they actually got what they wanted from the trade. So that's the derivative system. And then finally, we've created a system that can scan regulatory and financial reports, hundreds of pages of reports, and then find the appropriate source system, reconcile those, and it'll check footnotes, et cetera. It's just like a hyper aggressive spell checker, number checker, essentially, and that's been a quite successful algorithm as well.
One of the things you mentioned there, almost en passant, was an algo being used for anti-money laundering. And I wonder if I could just pursue that a bit, because one of the areas where the financial services industry seems to be wasting an awful lot of money, and I'm talking here of hundreds of billions of dollars a year, is on customer due diligence, checking individuals and companies for anti-money laundering, for countering the financing of terrorism, for making sure they're not sanctioned people, and so on. And yet they spend all this money, but actually the results are worse than mediocre. They're catching like 0.5% of all the money being laundered in the world, is one estimate I saw. Yet, so the return on that investment is absolutely minimal. So you've got this AI technology, which is very good at picking up anomalies, very good at error correction and so on. Can AI be applied to solve that problem of customer due diligence at much lower cost?
Yes, I can answer that in two ways. The first is the skeptical algorithm, which is you think about the hundreds and thousands of people that will call you to verify information. And, unfortunately, these are people that are doing this, hundreds of times a day, and they're, they're starting to eye glaze themselves. And so there's definitely a role for a skeptical algorithm based on certain mathematical trends and context in which something is asked, where even the right answer should be taken skeptically. So that's one thing. The second thing is, if you look at the difference between the U.S. Transportation Safety Administration way of finding terrorists and El Al, they're totally different and with very statistical meaning. So El Al has only had, I think, one crash in its entire life. And the US system has a much poorer track record. Now, why? Statistically, it's because the US system starts with the premise that every potential passenger is a potential terrorist. That is mathematically the wrong way to set up the problem, because the prevalence rate is so low that you will be burdened by false positives.
Mm-hmm. Yeah, say false positives are a huge problem in AML. It seems to be the biggest problem. Yeah.
Yes, exactly right. And El Al profiles people, and they essentially, which was viewed as politically incorrect in the United States at the time of 9/11. Norm Mineta and he was interned in a Japanese camp, and so he was very much against profiling. But profiling actually works because profiling reduces your data set, where the probability that what you're looking for exists is greatly increased. Even if it goes from 0.01% to 10%, the false positive rate is very manageable. So I think, using math in this case can really be of help. And I'm not an expert in any of these areas, but I think that's underlying some of the problems. But it is very solvable, definitely.
Mm-hmm. Now, we've talked a lot about getting rid of false positives, error correction, finding anomalies, and so on. But of course, firms exist to make money. They'd also like to increase their revenues. Can AI help people increase revenues as well as solve problems?
Oh, definitely. I mean, I think that any system can be used as long as it's beneficial to the customer and the customer realizes this is actually helping me. I think the customer is more likely to provide more assets to the right company. And I think that there are frustrating situations where customers feel that the human or a computer is just not understanding them. And so their EQ algorithms that promote sound investing, algorithms that don't treat you like anyone, but understand who you are. And believe me, people can tell. People can tell whether the app that they're interfacing with understands them. I mean, it's one of the most positive things about the use of AI in YouTube, and other social, Spotify. It's really truly helped to enrich the user experience. There's no question that those same principles can be applied in financial services.
Let me give you a real problem. I'm sure I don't need to tell you this, but in our business, of course, we see sales forecasts all the time from salespeople selling sponsorships and advertisements and so on. And those tend to be, shall we say, over optimistic. Can an AI help predict which sales are more likely to be landed and which salesmen or women are more likely to be successful or less likely to exaggerate their potential success? How do you deal with the problem of errors of optimism in sales forecasts, to put it crudely?
Yeah, we worked for a very large technology company where we essentially used a time decay algorithm, and it didn't really matter what you're scoring. So salespeople are very likely to have a methodology and a scoring system on what makes an opportunity more valuable. Those are often quite subjective, frankly, and highly subject to bias or skewing the number to favor an opportunity that you may like. Time is completely objective. The more time that passes, the lower the likelihood that you will close an opportunity. That's just the way it works, frankly. And we've done that in dozens of different use cases. So a time decay algorithm has been used quite effectively to true up a person's own beliefs about their sales forecasts and the actual truth. And it's proven to be very accurate. That's one way. I think there are many other ways. We've used algorithms that self-adjust and also look at seasonal trends to recalibrate forecasts, and they use sampling to do that. And we've found that we can increase accuracy by 45% or so.
The term you used for an AI algorithm earlier was that it was creative. In other words, the way I read that was that the AI can actually tell you things you didn't know before. It can also help you find opportunities you wouldn't have found unaided, and it can possibly help you or enable you to do things you couldn't actually do before. Is that another positive side of AI, that suddenly these opportunities start appearing, these pieces of knowledge start appearing out of your data sets, and funnily enough, you find you can actually do pieces of work you couldn't do before?
Oh, definitely. I mean, I think that the best thing about machine learning is, when I talk about reducing data sets, which is really what you want to be doing, it's almost surprising. It's never surprising to us that data we thought were previously important were not important at all. And so having algorithms tell you what matters and what doesn't matter is probably, to us, it's like time. Time is, honestly, it's one of the best variables ever in machine learning. And we always start with time as a variable on whatever we're predicting. We believe it's time for completing a nav or completing a transaction. A delay indicates something wrong. And so time is a great variable. But yes, the algorithms can show you things that you just didn't think were either possible, or it makes you release your biases on what you thought were important ways to evaluate something. I think as well, algorithms, I mean, I talked about root cause attribution. Causality, as many mathematicians know, is really hard. And we take it for granted. We think everything has cause and effect, um, and we just take for granted the fact that most of what we think causes something doesn't. I mean, I think the you know and we are conditioned and biased as humans to kind of not change our minds, frankly.
Yeah.
So that's where I think algorithms have been fantastic for us, at least.
And does it always work that way round? People often say to me, oh, well, we did an AI project, but we're a bit disappointed because we didn't know what we were looking for. What you're saying is actually the machine can tell you what you didn't know you were looking for.
Exactly.
Now, does that mean that if you're investing in AI, is it a cumulative activity? In other words, if you have success in one area, you find some things out you wouldn't otherwise have found out, and therefore you can other parts of your business start to become automatable, if you like, through or areas where you can apply machine learning algorithms. Has that been your experience, that success in one area leads to success in another? So is it a cumulative process in which AI and machine learning algorithms can eat more and more of your business?
Definitely. I honestly, I think that this is an area where mastery is quite important, and not just mathematical mastery, although that's very important too, but it's a fusion of math and industry knowledge and fact finding and experimentation. All of these disciplines are very important in machine learning, and it takes a lot of work to get better at it. And it takes an openness, which again, in my opinion, doesn't fit well with the software model. It sometimes doesn't fit with big corporate projects because, large bureaucratic organizations can find one fault in something and throw out the entire project. And there's no question that machine learning, it's not flawless. It takes a lot of iteration, a lot of mistakes before you get better. But when you get to that level, it's that level of mastery of knowing what outcomes to heed, how to make adjustments, how to fine tune. And in fact, there are people in the industry in machine learning that call some people machine learning whisperers, or AI whisperers, because they just somehow have a knack for an undescribable way of making algorithms work consistently. And I think that's just wisdom.
Bob, I'm conscious we've been talking a long time. I must let you go, but can I ask you one final? It's a slightly random question, and sure. I'm asking it because a lot of our members are presently engaged in blockchain-related projects, particularly in the area of tokenization, both of money and of securities, and indeed of various sorts of physical and virtual assets. Is there a point of intersection between artificial intelligence, machine learning algorithms, and blockchain, which is obvious to you?
I think there are a couple of areas that we're very excited about. I think on the one hand, it represents a way of not needing intelligent algorithms, because if intelligent algorithms are solely dedicated toward transaction inefficiencies, then having a smart contract or a more blockchain-based model will eliminate the need for intelligent algorithms in that realm. However, blockchain is still hackable. It's still reliant on attestations and observations, and I think there, intelligent algorithms play a huge role. I think finally, the idea that we discussed of algorithms being shared, I can see that as playing a role in tokenization as well, where, in other than tokenizing an asset pool, maybe you think of it as tokenizing an algorithm pool. and so there's that I'm very excited by it. I'm not threatened in the least by it.
Bob Suh, thank you very much for taking so much time to talk to us.